the water, wastewater, stormwater, and roading. Start with the roading, it's simple. What you need to do with the roading is, most of you found that chart in the council plans where it had the CBRs, and then you sort of take it through there, and you've got the different types of roads, and then it's got a bit of a pattern there, and it tells you that this bit's the base course and this bit's the sub-base. There's a bit in between that you all got confused about, and you need to go back and figure that out. There are not 3 layers in a road, there are 2. There's the sub-base and the base course. That bit in between is sort of irrelevant to what you're doing. So, what you need to do from here is you need to produce you need to figure out the pavement depth, thicknesses, the cross section, and just cutting and pasting the council cross section is not enough. You need to produce your own cross section, or typical cross sections, for the road. And once again, the council's giving those plans. So a lot of people just cut and paste it. Okay, a lot of people come late, so I'm going to repeat what I said before. If you should have got your marks back for your preliminary design, draft design. If you got 60% or less, you are in a lot of trouble. You are, unless you're really willing to commit long hours, you're probably not going to do it. You maybe got 100 hours of work to do over the next 4 weeks. So, wake up call, you can do it. This is not a course where we go, oh yeah, okay, we'll just squeeze them through. Okay, this is the course where you demonstrate that you are fit to be an engineer. You give me some half-assed thing that looks like a school kid produced, you are not going to get past. Okay, remember that thing is 80% of the mark. Okay, so keep that in mind. I'm not going to accept something that doesn't look like something an engineer should produce. This is a capstone project. You are supposed to be engineers. You are demonstrating that you are supposed to be engineers. Okay, so looking at the roading, pavement thickness, cross sections, and obviously the curves. So there's not much to do on roading. Okay, it's pretty simple. I know that Edward sort of taught you a whole lot of stuff. You don't really need to sort of do too much. There's maybe a page and a half of calculations plus that thing there. Okay, so with the roads you need to sort of come up with what does the cross section look like, what are the curves going to look like. It's a road, you don't have to design super elevation. It's an urban road, you don't have to design super elevation or anything like that. Any questions about the roading? Okay, so the water and the stormwater come down to the population. Okay, so you need to figure out what is the population, your design population. So I suggest that your first calculations is what is the design population of this area, because that will affect your water and your wastewater. The design population is the input for those sort of things. From both of them, you're going to figure out how much water is required, Q peak, if you like. So, how much water is required? How many people are there at the peak flow? That is sort of when everyone's having showers and drinking water and using the toilet and stuff like that. There's a peak flow, litres per second. Now, in the guidelines, it'll tell you what the required diameter is. But you don't even have to design the diameter for these pipes. You find it in there and you say, this is the diameter that is recommended for this type of development. Okay? And so you're going to be given that. Okay? And you also, once you figured out the population, you can figure out what the peak flow is from that population. So that many people are going to require this maximum flow going through the pipe. And remember, it's not the average flow, it's the maximum flow. And what you need to do for this water thing is you need to say, with a pipe of that diameter, can that flow go through it? Yes or no? So QP, Q peak is less than Q capacity, if you like. So that's the capacity of that pipe. That is all you need to do. You're given the diameter, you need to figure out the peak flow, litres per second at the peak time, so there's peaking factors and stuff like that. And then you just need to demonstrate Q, that the peak flow is less than the thing. So the problem you're going to have there is what's the head, so 20 metres head is minimum. So the pressure differential across the pipe is going to be 20 metres, okay, 20 metres head difference. So with a 20 metre head, driving that flow, driving it through the pipe of that diameter, what's its capacity? What's the maximum flow? And all you need to do is that equals that. Okay, so any questions about that? Okay, yep.
Just a question, this is, like how we design, it's a development, right?
Yeah.
And we design the flow for people living.
Yeah.
But have we taken into consideration fire?
Yeah, so the Q peak would be also fly flow. So everyone's having a shower, everyone's sort of preparing their drinks, and there's a fire on. Okay, so you've got a peak factor. So that water, there's water for the fire, there's water for people having the showers, there's water for people preparing the kitchen stuff, all of that stuff. Okay, and you need to say, will it get through it? Now the other thing to remember is that the water has two pipeline sizes. There will be two diameters. One will be for the mains, and one will be for the feeder. Rider mains. Okay, so the way it works with the water pipeline is you've got holiday houses on both sides of the street. And you've got a road there. What you don't do is you don't have one pipeline going along there and these ones are fed across the road. What you do is you have one main pipeline which has the hydrants on it, so you need to identify where the hydrants are. And then you have another pipeline, which is the rider main, which just services those pipes. So it has the hydrants and it services the pipes. So the main serves the whole thing, and then they're connected. And you also need to figure out the valving arrangement for the connections and stuff. So you've got the mains, and you've got the rider main. The idea of the rider main is just to supply the houses on that side of the street. The mains is carrying all of the flow, and if there's a fire, the hydrants are sitting on the main. So those are the two different types of pipe. If you look at the council plans and stuff, I expect you to have a plan of the whole water system. I expect you to have a closed water system, so there's no dead ends. I expect you to show me where the hydrants are, and I expect you to show me where the valves are, so on your drawing. Any other questions?
If the water is coming from an existing neighbourhood,
Yeah.
does it have to be taken
No.
into consideration?
So, in real world, you would be required to look at the existing systems that you're taking out of and you're feeding into. You'll be required to do a calculation on those. I'm not asking you to do that. You just assume that those existing systems are going to be able to supply the water you want and take the water you're feeding into it. In the real world, you'd actually be calculating the whole system. Okay. Any questions? Now, the water, so this is a pressure system. You don't need a cross-section for it because the pipe is driven by a pump off in the distance. The depth of the pipe doesn't really matter. It can go up and down, and so you don't need a long section for that. For the gravity system, for the water system, it's a gravity system. It's driven by gravity. It flows downhill. So there's a different set of calculations for this. For this one, you used to assume there's 20 metres head across the pipe. With this one, it comes down to what is the slope of the pipe. So that means that for the wastewater system, you have to figure out your layout of the wastewater system. You need to figure out that, I've got my houses and stuff. I've got the pipeline there, I've got these houses feeding into it, and they're going to a main there. So you need to say, okay, well, and there's maybe a manhole there. So you need to figure out where those manholes are located, what their level is, and then look at them and say, okay, well, there's the pipe slope there. Okay, so that is your hydraulic gradient. Remember, it runs under gravity. So that is your slope. Once you know the slope, then you can figure, and the other thing about wastewater is that they give you a diameter minimum. There is a minimum diameter for wastewater pipes. You will find it in the council guidelines. All you need to do is say, quote where you got it from, pipe diameter equals 150 from blah 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 blah. A lot of you just cut and pasted all the tables from the council guidelines. I don't want to see that. I just want to see you quoting them. Your job is to pull that information out. It's not to stick the table in and say, you figure it out yourself, okay? You need to tell me where you got that information from. So, with the Wallingford chart, if you know what the design diameter is going to be, and you know what the slope of it is, then you can figure out what the Q is. And so once again, you need to figure out what the Q, the capacity of the pipe is. So the first thing you need to do is you need to figure out, sorry, I'm getting confused, the flow at the peak time. So you figure out how much wastewater are we going to get, population, how much wastewater does each person do. There's peaking factors, everyone's going to the toilet and having a shower at the same time. There's a peaking factor for wastewater as well. You come up with a number which is the peak flow, peak design flow from the community, litres per second. Once again, you need to say, can that peak flow go through that pipe? Is that pipe big enough to carry that flow? Don't worry about minimum flows. Your job is to say, is this pipe big enough to do it? And then all you need to do is you need to show me once again QP is less than QC. In other words, the peaking flow from that population is less than the capacity of the pipe. The pipe can carry the flow. If it does, okay, tick. And as I said, the Q capacity, if you know what the diameter is, which is given by the council plans, and you know what the slope is, which comes down from you doing a preliminary design for the pipeline, that will tell you what the Q capacity of that pipe is at that slope. So remember, the capacity of the pipe comes down to the slope and the size, the diameter. The diameter and the slope, that's what drives it. Bigger diameter, more flow. Steeper slope, more flow. Okay? So once again, you need to show me the Ease and Wallingford chart. So those two should take maybe a page each. They're not big calculations. Maybe a page and a half of water. So the stormwater is also a drainage system, and you do not have the a set pipe diameter. You're going to have to figure that out yourself. That's what the design process is. So with that, for the capacity of the pipe, you need to come up with catchments. So you need to split it into catchments. And so once again, this is you designing the stormwater system, the plan, and then the long sections. And you need to design every pipe. So what I don't want to see is you saying, okay, there's two catchments, one going that way, one going that way, and I'm just going to calculate it for that. What I want to see is there's a pipe there, a manhole there, manhole there, manhole there. I'm calculating the catchment for this pipe, and this manhole, and I'm calculating it for this pipeline as well. I want to see calculations of each of them. So what you need to do is you, you need to split it into catchments, and catchment is where the water flows. So once you've decided on what the layout is going to look like, and you put your manholes in, then you start splitting it into catchments, and you say this much flow is going into it. And then you calculate the quantity equals CIA over 360. Okay, that is the quantity of flow that is going to be coming into your pipe system. QIA over 360. I'm not asking you to use TP108, I'm asking you to just use the rational formula, which you should all know. So that'll tell you how much water is flowing into that pipe. Then you need to calculate the pipe diameter. using the Wallingford chart. The things you know is the flow. So in this case, you're doing it differently from here. You're saying, okay, there's the Wallingford chart. So for the Wallingford chart, given two parameters. So Wallingford chart has the flow, Q. It has the slope. It has the velocity, and it has the diameter. With any two of those parameters, you're able to calculate the other two, just by intersections. So the two parameters you have for stormwater for each pipe, and I want to see a calculation, so you'll have multiple calculations for this. For each pipe, you will have a flow, Q, from the catchment. And you will also have a slope from your design. And then you will calculate what pipe size do I need for this particular pipe, giving the flow from the catchment and at that particular slope. So those are the two parameters you have. Q from Q and slope, which is HL, whatever it is. So I'm not sure what you guys call it, but the slope of the pipe, because it's a gravity system, remember it flows under gravity. Any questions about that?
Hugh, you get the final slope, they're, once again, are they tying into something over here?
Yeah, so you just assume that the pipe is actually going to be okay. So this is the existing one, so this might be an existing manhole.
Yeah.
And you're assuming that it is able to take that flow away.
Right, and also by memory, if you end up going at a right angle, doesn't that affect your
Yeah, not even getting into that.
okay. Right. Sorry.
Yeah.
It's
When
just-
you
it's
when you
just-
are designing your pipes,
Yeah.
I don't want to see any acute angles. Okay.
Okay.
I don't want to see you saying, "Oh, water's going to go like this, and it's going to go like this." Water doesn't do that. Okay. Water goes like this
So I just,
at a maximum.
well, in industry, I had to do quite a few of those.
Yeah. So in reality, you'd also calculate the losses in the manhole,
Yeah.
entry losses, and you know you probably get full marks if you do that. You know, at present I'm telling you what you're going to get to sort of get something acceptable. So, roading. There's a chart there. It's going to be one page. You just need to find that chart. You also need to find the typical cross sections. You need to produce your own cross section and the drawings with that. And you need to show the pavement thickness and you know all the features across the road. And you also need to have a plan. This is the plan showing the road. Okay. Water and wastewater. I suggest you start with the population. What is the population that I'm saying? And you will have different populations from everyone else. I've deliberately not told you what the size of those buildings are. You need to make an assumption. And I'm hoping that everyone comes up with a different assumption. Water and wastewater is just with that population, what is the flow that population needs? What is going to come out the other end of that population? You've been given the diameters of the pipes. Are those pipes big enough to carry the water in and to carry the wastewater out? Okay. Stormwater, it's going to take you maybe 2, 3, 4 pages plus a whole lot of Wallingford charts. Every one of them should show me how you arrived at that. You're probably designing 4, 5, 6 different pipelines, not one. Okay. You should be starting with your plan, splitting into catchments, figuring out what those catchments are, and then from each catchment using that to calculate the pipe thing. So obviously, when you're designing this this pipeline here, you've got the flow coming in from the catchment that serves that area, but also you've got the flow that's coming in from the top catchments as well. So you've got it's a bit of an additive thing. So you start at the top and you work your way to the bottom of the system. Any questions? So what I suggest you all do is you get the calculations and start your drawings. So you need to do the plans and some of the long sections. And as I said, you may well be repeating yourself several times to sort of get the right design. You might think, okay, that's not. Now, the ground you've got out there is perfect the way it's shaped. Okay, you don't need to do any cut or fill from the whole thing. It's actually going to work perfectly for these gravity systems. Okay, it's more than 1%. It means that you can sort of keep your pipes at minimum cover, which is sort of 1.2 below the invert level.
1.5, I think so.
1.5, whatever. Make an assumption. Say, assume minimum cover is 1.5 to invert level or over top of that. And as I said, you do the drawings and the calculations and then some. So there is work to do. There's quite a lot of it, but you know, it's still doable. Any questions? Has anyone got their finished thing that they'd like to show me and would like to talk about? So what happens from here on in? I've told you how to do this. I'm happy to sort of explain stuff to you, but I can't explain anything to you if you haven't done it. I can say you've got this wrong, or you've got this right, or that's looking good, or that's not looking good. But with those drafts, there wasn't much I can tell you really. Okay, so most of you have sort of given a bit of a go with the first bit. That's only worth about 20% of the whole report. The guts of it, sorry, 40%. The guts of it is the calculations and the drawings. So I suggest you focus on that to the exclusion of everything else. Okay. Any questions?
What is the date of submission?
I don't know. What does it say?
1st of June.
1st of June. So that's what? Month. Golly. You're really going to have to be rumbling. So, these sessions, I'm going to be here, Roger's going to be here. If you want to know anything about drawing, ask Roger, because I've got no idea. Okay, you need to get those things in, and so I'm happy to sit, if you bring it in and say, look, you know, I'm having a few problems with my calculations, here's what I've done, then I'm happy to work through with you. But this is the last time I tell you what you need to do. Okay, I need to see that you're actually doing some movement rather than sitting around waiting for me to do it for you. Okay? This might be a short session if no one's got anything for me to show. So, as I said, I'll be here for that hour. If you can't make it, you know, if you've got some other questions, email me, but I'm not going to we're not going to walk you piece by piece. I've done this, now what do I do? Okay, I want to see. These are my calculations. Does it look right or something like that? So bring that in and I'm happy to comment on it.
Huda, asking me about marking and feedback. Are they, what have we got for them so far? We did the presentation.
Yeah.
Was there something before that was marked?
I think they're probably all, I think we've done all the marking on these. I just haven't opened them up yet. So I'll open them up now.
Okay.
Yeah. So I probably haven't released it. But I mean, you all got good marks. You're all sitting on, you know, a reasonable mark. But as I said, we expect a pretty professional presentation for this report. This is where you show us that you're fit to be an engineer. Now, what'll happen, you'll hand in your final reports, then the next week there'll be an interview, and the way it'll work is I'll call you in, I will put your report up on the screen, and I'll flip to a page, and I'll say, explain this, explain that, and most of it will be the calculations and the drawings. It'll be, or me and Roger, it'll be, you know, so you might have put this in here. So I might say, well, what's the C mean? How did you get the C? Where'd you get it from? You need to be able to explain it to me. How did you calculate the A? Where did that come from? So if you've done it, if it's your own work, you'll be able to answer that immediately. Okay, if it's not your own work, then you go, oh, I don't know, I got it from the... So answers that are not acceptable are, oh, my mate told me to get it. I got Edward's lecture notes and just changed the numbers. Or I guessed. Okay, those are not acceptable answers. They show me you do not know what you're talking about. So when I ask you to flip to any page, I should be able to do it. Likewise, when we flip to your drawings, we're just going to ask you, how did you produce this shape? How did you produce this piece of, how did you use AutoCAD? And so if you can't tell him immediately how you did it, then you didn't draw that picture, okay? By the time you finish this, you're going to know exactly how you drew the drawings and stuff like that. If someone else did it for you, if you got AI to do it, or if you just didn't do it without understanding, you can't answer the questions. And as I said, the way it works is we give you a percentage on the interview. How much of that interview were you able to answer? Every year for the last 2-3 semesters, I think only one student has not got 100% because you've all done your own work. So if you do your own work and it's a crappy job and it's only worth 60, you still pass. If you've copied it and got your mate to do it and you can only answer half of our questions, you get 40%, 80 times 40, 80 times 50, and you fail. So that interview is not a problem if you've done your own work. It's easy. It only gets hard if you haven't done your own work. So there's no more questions. Probably the shortest session I've ever done.